Hello and welcome to the McHale Report podcast. My name is John McHale, Group Editorial Director for Military Embedded Systems and host for today's event. Today, our guest is Eliot Fine, Product Line Manager for Space and High Reliability Components at Analog Devices. And today we're going to talk about the military space market, rad-hard technology, MOSA, and much more. So, Eliot, welcome, and
Thank you.
I'm glad we're here. I know we had a chat a few months ago about this, talking about space tech. I said we got to get you on a podcast, so here we are. So can you tell the audience a little bit about your experience in the defense and space industry and your responsibility with Analog Devices and your group's role within the overall larger company?
Yeah, absolutely. So first of all, good to be here. Thanks for having me on. So I've been with Analog Devices for about 6 years now. The first 5 of which were in the sales team, customer office. So I had direct customer engagement, and for much of that time I was working with aerospace and defense customers, and specifically with the space end market. So I got to know the market fairly well in those years. And then so about 9 months ago I moved into a product line role. So I've been with this group for just shy of a year now. Analog Devices is structured by verticals at a broad level, and then so that would be aerospace and defense, and then into technical groups that have product responsibility and do product development for those particular technologies. But we are sort of a unique and particularly exciting technical group at ADI because we're not doing just one thing. We're not making amplifiers. We are instead producing high-rel components and solutions for the space market and for other applications that may require that degree of high reliability. So we will get to leverage the broad breadth of ADI's technology. There's a vast IP portfolio at ADI, and we get to pull from all of that, which is really exciting. And so we'll actually partner with the silicon design groups to help them think about space as an end market as they're doing their early phase design. So we end up being a mix between a business unit and a functional unit in terms of how we interface with the rest of ADI. We have product development, radiation effects, and marketing all under one roof, as well as some operations and program management folks. And so we try to cobble all of this together to provide a good breadth of offering for our customers.
So we teased that we're going to talk about the space market, so let's talk about it. I feel like, as opposed to decades past, and I say decades, it feels like the space market's moving a little more fast for a lot of reasons, the commercial world, et cetera. But from your area and what you guys design, what is the hottest applications? Is it small sats, longer life satellite programs, classified, manned space flight? Where are you seeing the most activity? It's a good way to say it.
So, this might be a cop-out answer, but all of the above, right? We're still seeing those classified missions. We're still seeing some manned space flight, but small sats, shorter mission lives, and proliferation are starting to become a trend more and more. Especially so it's not only with the commercial world but also with the military and aerospace world, and we have a long history supporting all of the types of programs mentioned, from things like the James Webb Space Telescope to a handful of classified programs. And we get to, as I said before, we get to leverage our breadth of technology to support all those various mission applications. Short answer is we see it all, but definitely that trend towards proliferation is a fairly common one.
And what about one of the common things you have to do for what makes, I guess, the development time for space products a lot longer is qualifying them for space. We're talking radiation-hardened designs, or more properly to say rad-hard. So what are the factors driving rad-hard designs today? In other words, what kind of requirements you're getting from your defense customers for rad-hard components? What's the trend?
So as we said before, the industry is trending towards that proliferation. They want broad-based coverage for communication and threat detection. It's no longer looking at single sort of points of interest. It's really this, we want a broad network. So and not only in LEO, but also moving towards MEO and GEO proliferation. We're not doing the single or couple point GEO satellites anymore. Speed is definitely critical, right? That, as you said, that rapid deployment, being able to leverage commercial solutions to get something up into space faster. There's no time for boutique solutions anymore. And customers are looking for bleeding edge technology to be able to leverage in their applications. We've I think we're moving away from the days where products that were defined before I was born are still used commonly in space. And there are quite a few products, even in our portfolio, that are old and we still support and will continue to support. But we want to look to pulling in as much modern technology as possible. And you touched on something there about how we qualify things for space and that is a long lead time. So we can talk about this more as we go, but we're doing what we can to try to shorten that lead time. We want to leverage our commercial solutions as much as possible, and we want to also intercept our product line designs earlier in their design cycle. So we're not waiting until the commercial silicon is released as a commercial product to then go back and say, okay, can we turn this into a space qualified product? Can we modify the silicon? We want to instead work with them early on to define something that's dual use, that can service those commercial applications and can also service the military market with some minor modifications.
Is that kind of what I've heard about with the 80% solution when it comes to rad-hard design? If I don't need mega rad-hard, I'm not going to pay for it. So is that what you're going after with that part of the market?
Absolutely. And customers want, so our customers are more cost sensitive than ever. More programs are firm fixed price. They're looking for ways to deliver on time and in budget. And a good way to do this is adjusting the requirements to meet the real demands of the mission profile. You don't need a mega rad, as you said, for a 3-year mission life LEO application. So we try to offer a breadth of screening and test capabilities so that customers can pick the right thing for their mission. And we would ideally like to have the same product or same product family with an offering that supports a short mission life LEO, something that's might be more medium mission life, and then a deep space long mission. We want to try to have that suite of offerings for our customers so that they can pick and choose what they need based on the application.
And the speed is important, but also I think you mentioned there's more, you see a lot shorter life programs up there. You don't have the 15-year life cycles for satellites anymore. That's where the stuff that was built before you were born is still flying up there. But I mean, there's not a need for that anymore. And I think that's driving also as you said, the shorter lifespans of the satellites or whatever it is that's going on the spacecraft is driving that demand for less rad. They don't need to last forever.
And that's reducing the focus on total ionizing dose as a metric. So single event effects and single event latch up is still critical, because you can't have your parts fail in space if there's a solar flare or something like that. But if the mission life is short, we don't need 200K rad TID. Many missions can be good enough with 10, and then that opens up a broader door of what types of products are available and what type of products we can qualify for space as well, because we may not need to redesign or design in a different process to get that 200K rad threshold.
Okay. When we talked last time, you talked about a concept called the RF signal chain, which I've heard about from analog devices before. You said you are trying to push that into the space market. What do you mean by that? And how did the signal chain, to kind of tell me what it is, what is on the chain, and what is it doing in space?
So at Analog Devices, we want to be system providers in general for our customers, whether that's actual, complete modules and systems that we sell to some of our customers, versus or that's offering a breadth of components that can be put together to meet a whole signal chain or a power chain or something like that. So we're using that same mentality in space. So we're positioning ourselves to support the radio in space. Everything from beamformer to bits and back. We want to be that solution provider, whether it's as a complete system or as a suite of components that can get you to that complete system. So we have a strong portfolio of beamformer ICs, RF amplifiers, control products and detectors, frequency conversion and generation, RF transceivers, and high-speed data converters to allow our customers to put together that whole radio in space.
And I think part might contribute is open architectures as well. And that's kind of, this is my thing I like to talk about a lot because we cover MOSA, which is the modular open systems approach, the mandate from the DoD that came out in 2019. It's been reaffirmed last year. How's that impacting military space designs? Is that factor into how you build the RF signal chain? And does it go in hand with this push we hear about towards leveraging COTS components in space?
Yeah, I think it does go hand in hand with leveraging COTS. They come from that same core need where customers want increased speed and agility among a rapidly changing environment. Everyone wants faster time to market, and they rarely have time to be bespoke. So it does come from that same core need. Actually, in your magazine, you had a great article from Don Zoldi a couple of years ago on what Lockheed Martin was doing to create platform architectures and how they were digitally modified for different missions and applications. That trend has continued, I think, and I'm seeing a similar approach at many of the major players in the industry.
And with COTS, I remember for years covering the Radhard. I'd go to NSREC, the Nuclear Space Radiation Effects Conference, and COTS was the four-letter word in the space market because it had that word commercial in there, right? And they said, no, we're not Radio Shack. We're not that. Radio Shack's out of business now for most people if you want to know. But but now you're seeing it because you're seeing whole COTS satellites going up there and the constellations, the mega constellations, and also if it fails, we'll just have another satellite up there to fix it. So that's kind of driving all these lower costs, the shorter the life cycles of the actual spacecraft. So that means more requests for COTS in space. And how do you meet that demand for COTS while maintaining reliability? I think you touched on it a little earlier with how you guys develop from the ground up, but is that what you were talking about a little bit there?
Yeah, so part of it is developing with space in mind because that's going to get help those commercial product lines within analog devices think about space as part of the requirements for their product. But the other thing we're doing is we've created these flows specifically tailored at sort of step down tiers from that traditional space class V type product, where we have commercial space high or CSH that is leveraging the native plastic package, leveraging some of the cost efficiencies of commercial manufacturing, the reliability that comes with commercial production scale, actually, because you get lower fit rates, failure and time rates when you're producing in mass versus producing just a couple units at a time. And so we leverage that commercial manufacturing, but then we still put that product through a full QCI and 240-hour burn-in. So it's sort of like a best of both worlds scenario where you use that plastic product, you get the smaller form factors, you get more modern technology, but you still have a lot of confidence that you're not going to have like early life failures, infant mortality with those products. And then stepping down from that, we have our commercial space low offering, which is essentially like a space enhanced product where we've done some things to validate the product for space. We'll offer radiation testing on that product. And we will offer wafer lot traceability. We'll make sure there's no pure matte tin lead finish, things like, little things like that take it a step up from the COTS. But basically, you're getting a COTS product or COTS-like, and we can price them much more aggressively because we're leveraging our commercial manufacturing flows. So we're trying to offer different things for different missions, right? And we know there are going to be some missions where pure commercial off-the-shelf or automotive products are going to get used. We want to support those customers too. We're not here to tell you have to use a certain type of product from us. We want to have an offering that can support different types of missions for different lengths with different types of products.
So the commercial business, I remember asking some folks in your radar stuff about this years ago. Is that for the automotive commercial business? Is that because it's such a higher volume than a commercial in military space radar, whatever? It's always a higher volume in the commercial world. Is that larger volume of business also help you with your production or driving costs down or lower yields? How does that impact?
Absolutely. So the answer is yes to both. It helps us lower production costs, of course, because we're producing at scale, and it does mean better yields and better reliability. We can with high volume commercial manufacturing, there's a lot of confidence that you can just get right off the bat around the production quality, especially I would say with a quality first organization like Analog Devices.
Okay. So we're getting kind of to the end of the podcast, and this is a question I throw out of all my guests is I want you to predict the future, so to speak, from a disruption standpoint. What do you see being a disruptor in the space market? Is it going to be a technology? Is it going to be a procurement strategy? A couple of years ago, I had a gentleman in the space industry say it's not a technology, it's people buying cots in space was a procurement strategy. But what do you see? You're kind of close to the design side. What's a game changer down the road here?
My prediction, so I think, procurement strategy is valid. I think that's already happening. I don't think that's the future. I think that's now that the procurement strategy is changing. But I think the big changer 10 years from now will be the intelligent edge. We will see significantly more compute power on the satellite itself. So AI can be leveraged to pre-process the data before transmitting back to Earth, which reduces the packet size that has to come back and reduces power up there. And then this, dovetails into autonomy, autonomous maneuvering, broader connectivity, both on Earth and in space. And then I think even farther out, but maybe not quite as far as we think, the lunar economy will start to pop up, and we're already seeing seeds of that planting around as I talk to customers in the space market.
Get to the lunar economy part in a second. But so when you define the edge, the intelligent, it's basically where the data is collected by the sensor and the satellite, correct? That's what you're talking about, the edge, right? Okay, I want to make sure I get that right. So some people say the edge in the military is where you engage the enemy, regardless of domain. But from a sensor standpoint, it's where you collect the data and getting that AI technology up there, which means faster performing chips.
Thank you for clarifying. Right, as opposed to just pumping all your data back to a data center that's going to process there. We're Analog Devices, I think, really well poised to be a leader at the intelligent edge and to manage all that data at the sensor source.
And to invest in the lunar economy, maybe you can have the first foundry on the moon.
There we go. Right.
That works, right? Well, Eliot, thank you for talking today. That brings us to the end of the broadcast. I enjoyed the conversation. I'm glad we got to do this after chatting about it a couple months ago.
Me too.
I thought it was good. You did great.
Overdue.
Yes, absolutely. So good luck with the RF signal chain. And thank you to all of my audience for listening to today's podcast. Look forward to seeing you in future broadcasts.